Today we're going to take a look at how do we solve compound inequalities. Hopefully last year you had some practice graphing some of the compound inequalities. So today we'll take a look at how do we solve and then kind of review that graphing as well. Everything that we've looked at so far have been what are called simple inequalities because there's only been one inequality symbol for every single problem that we've been working with. Compound inequality has two or more inequalities that are connected by the words and or the word or. So if I look at this first one, we have the inequality of x is greater than or equal to 2 and x is less than or equal to 4. So what that and means is that it has to satisfy both conditions. And so you'll take a look at the graph here and you'll see that x is bigger than 2, but x can also be smaller than 4. And because it's the word and, it only includes that little piece right there. Most of the time, compound inequalities with the word and are not written like this first one. Normally we see them written like this second one here, so that way we can kind of condense it down as much as possible. And I personally like using this one better too, because this one tells me when I'm shading, because the x is in between the two inequality signs, that I'm going to shade in between the two dots. That's what I think about with the word and. The word or, on the other hand, means that it can satisfy either this inequality or it can satisfy the other one. So here we have x is less than or equal to -3, which is shown here, or x can be bigger than 2. So some students will ask the question like, when would you ever have an or inequality in real life? This actually happens all the time when you go to like Valley Fair or you go to a restaurant or something. Like I'm going to use a Valley Fair example that I'm going to say children under the age of 3 get a discount, and then senior citizens like 65 and older get a discount. So that's an example where you either have to be really young or really old to get the discount, and everyone else in between like pays the regular price kind of thing. So we do see or inequalities in our daily lives as well. What we're going to do first, in case you don't remember from last year, is we're going to do some practice on how we graph our compound inequalities. Like we've done earlier, we do need to make our number line. And the one thing that's different with compound inequalities, because all of them, you'll notice, have 2 numbers in them. With compound inequalities, I'm not going to make you put 3 numbers like I've had for the last couple days. You just need to make sure that these 2 numbers are on your number line in the appropriate order. So -3 is our smaller one, so I'm going to put that one first. And 5 is our bigger one. Both of these inequalities do not have an equal to sign on them. So we're going to put an open circle on both of our numbers. And here's how I always think of it is. The n is situated in between the 2 inequalities, so you're automatically going to shade between them. And let me explain why that's the case. Here this is saying that n has to be greater than -3, and that's what we're showing. And here n has to be less than 5. And again, we're showing that we're shading to the left in this case. But again, if the letter is situated between the 2 inequalities, just think about that you're shading in the middle. When you're working with an or inequality, these are ones that go to opposite ends. So again, I'm going to put my 2 numbers. 3 is smaller, 6 is our bigger. Graphing x is less than 3, open circle, shading to the left. X is greater than 6, open circle, shading to the right. So you'll notice with the word or, because you have 2 separate inequalities, that those graphs will always go out. Now as we take a look at this next inequality, notice that we do have 2 inequality symbols, but notice that they're connected and the letters directly in the middle. So this is an example of an and inequality where we'll end up shading in the middle. So again, I'm going to make my number line, putting the 2 numbers that are given in my inequality, smaller number first, bigger number second. The 8 is associated with a less than or equal to sign, so I have to fill it in. And then the 14 is associated with just a less than sign, so it's an open circle. So it is possible, and actually more often than not in real life, you're usually going to have one that's closed and one that's open. So that can happen. And then because my letter G is situated in between, I'm going to connect those because we want to be in between those two numbers. Let's take a look at this one. So this one I have an or, and with an or it'll always say or. There's no other way to write them. So that one we automatically should know that my graph is going to go out in opposite directions. So putting my -9 because that's smaller, 0 is my bigger one. X is less than or equal to -9, so that's a closed circle, shading to the left. X is greater than 0, again a closed circle, and shading to the right as well. Now we're going to take a look at how do we solve our compound inequalities. The great thing about this is that all the steps that we've been learning earlier this week work exactly the same thing with our compound inequalities. We still undo addition by subtracting, subtraction by adding, multiplying by dividing, and division by multiplying. Same rules apply as far as if you're multiplying or dividing by a negative number. Bells and whistles are going off in your head because you need to make sure you flip the inequality sign. Anytime that you're working with inequalities, you always have to remember that big rule of multiplying or dividing by a negative. The only thing that's different with this one is that we have the two inequality signs. So just like what we did earlier when we're solving and we put that line through the inequalities, this time we put it through both of them. And what we want to think about is whatever we do in the middle here, we end up doing to both sides as well. So we have to make sure we do it to both sides of our inequality because we want to make sure our inequality is still balanced as well. So hopefully you guys would think, to undo addition, we're going to subtract. So I'm not only subtracting 2 in the middle, but I have to do it on each side as well. So this goes away. 7 minus 2 is 5. We did not multiply or divide by a negative. Inequality sign stays the same. I only have z in the middle. Again, inequality sign stays the same. And 11 minus 2 is 9. There's my solved compound inequality because I'm only left with a letter in the middle. Let's graph. 5 and then our 9. Open circle at 5, closed at 9, and my z is situated in between the two inequalities, so we shade in between them. Let's take a look at these two examples. Now this first example is a little bit different because this one has the word and in it. That can happen sometimes. So what we want to think about for this one is just solve both of these inequalities on their own like we've done earlier this week. The only thing is we're going to put both of the graphs on the same graph together. So let's think about solving this first one. Line through that inequality. -7. So x is less than or equal to 3. And then let's go ahead and solve our other one so that way we can have both of our inequalities to be able to graph them. Same thing, line through our inequality sign. Minusing 7 on both sides. 6 minus 7 is -1, less than or equal to x. Now be careful with this one because this one, remember, this is our weird one where the x doesn't come right away. So you want to think about writing it on a piece of paper with a permanent marker and then flipping it over to see what it would really look like. So I'm just going to flip that over for you guys because that'll make our life easier for graphing. My smaller number is -1, bigger number is 3. 3 has a closed circle, so does -1. I want x to be less than 3, and I want x to be greater than -1. So notice that again, this is still an and, so I'm shading in between the two dots. 99% of the time, if you're dealing with an and inequality sign, you're shading in between the two. There are obviously exceptions to that rule, but think about ones that I'm giving you. If it's an and, you'll be shading in between. Now let's take a look at this next one. This is an example of an or. So I'm going to be taking a look at solving each inequality, and I know when I graph them that they should be going out in opposite directions. Again, there are exceptions to that rule as well, but most of them that I'm going to give you, they will be going out in opposite directions. Line through our inequality sign. subtracting 1 on each side. So A is less than 3. Solving my other one. I need to add 1 to each side. So A is greater than or equal to 4. And technically you're supposed to have the word or in between them, but if you don't have it, whatever. Let's go ahead and graph. Smaller numbers 3, bigger numbers 4. Open circle at 3, and because I'm less than, I'm shading to the left. Closed circle at 4, greater than, so I'm shading to the right. And again, this graph makes sense because I'm thinking about an or, so it should be going outward. Now, of course, when we take a look at compound inequalities, they're not all going to be one-step inequalities. We might have those two-step inequalities as well. So let's take a look at this one. Again, I'm seeing it's an or, so when I graph it, my answer should go out for my graph. But let's look at solving each inequality on its own. Line through the inequality, minus 7. (17 minus 3 is 6. Dividing by -2, bells and whistles. I said dividing by a negative. So I have to flip the inequality sign. So instead of the big end coming first, I need to put the little end. So x is now less than or equal to -3. All right, let's go ahead and take a look at our next one. And just because I'm a little crunched for space here, I'm going to rewrite this one off to the side. So I have a little bit more space to work. Line through the inequality. Again, undo this addition by subtracting. I did not multiply or divide by a negative. Inequality sign stays the same. 37 minus 12 is 25. And dividing by 5, I'm dividing. But I do not need to switch the inequality sign because that was a positive 5. So x is greater than 5. Now let's go ahead and graph then. Smallest number is -3. Biggest number is 5. X is less than or equal to -3. Shading to the left. X is greater than 5. Shading to the right. And again, this graph makes sense because it's an or, so we know that we should be shading outwards. Let's take a look at some compound inequalities where, again, we have 2 steps to be able to solve them. Let's look at our first one. This is an example where my x is situated in between the 2. So this is where I put a line through both of my inequalities. And I'm going to solve by doing whatever I do to the middle, I'm doing it to the outside as well. This is an example where I would add up here because I see that there's a negative in front of my x. So I'm going to add up just to make sure I don't get confused as far as, is that a -2, is that a +2? Now we clearly know that it's a negative. Then let's go ahead and solve. I want to get rid of this negative one first by adding 1 to each side. -2, I did not multiply or divide by a negative. Inequality sign stays the same. And I get 6 on this end. Dividing by -2. And again, bells and whistles. We divided by a negative, so I need to flip my inequality signs. So instead of the little ends coming first, this time it's the big end. And if with 1 is greater than x, which is greater than or equal to -3. Be careful when you're graphing this one, because again, we always put the smaller number first. So I need to put the -3 first and then the 1. -3 is open. I'm sorry, -3 is closed. The 1 is open. And again, my x is situated in between the two, so I need to connect them and show that I'm shading between the two numbers. Let's take a look at an OR. Again, I need to solve each of the inequalities. Adding 5 equals, whoops, I put an equal sign in. Less than, there we go. Dividing by 6, x is less than 2. Or, depending on what happens with this other one, minus 1. Again, I didn't multiply or divide by a negative, so inequality sign stays the same. Same thing here when I'm dividing by 8. Inequality sign will stay the same, so x is greater than 3. Again, technically there should be an or between them, but not the end of the world if you didn't do that. Smaller numbers 2, bigger numbers 3. X is less than 2, and x is greater than 3. There's how we're solving and graphing compound inequalities. Not only should we be able to solve them and graph them, we should also be able to go from a graph to be able to writing the compound inequality that would match that graph. Here's how I always like to think of these. If you're shading in between, you know right away that your inequalities are going to be situated around your letter. You can pick any letter that you want. I always tend to pick X. I've had students who always pick the first letter of their first name. That's fine, doesn't matter. But because we know that we're shading in between, I know that my X has to be in between those two inequalities. And always put the less than ones there. That's just a given as well. Now let's take a look. Both of these circles are filled in, so both inequalities need to have equal to. My smaller number is 1, and my bigger number is 4. So what I'm saying with this inequality is that my values for x fall somewhere between 1 and 4. Now in this next example, this is an example of an OR, because again, we're shading out. So I know that I'm going to have an OR with this. And whenever we're writing a compound inequality, or I should say any inequality from a graph, always put your letter first, because then that matches everything else that we've been doing for our graphing. I want x to be less than -2, so I put the little n first. And again, here's a hint that I always tell my students. You're shading in this direction, so you want to think about that the arrow is pointing towards that direction. So the arrow of my inequality is pointing to the left, so that matches. Same thing as I'm looking at this other one. My graph is going towards the right, so I want to think about putting in the greater than sign. And then the one that goes along with that. The ORs tend to be the hardest for students because they struggle with which inequality sign to put here. But if you know, always put your letter first, and then the inequality sign will match the direction in which the graph is going. That will be helpful for you. Let's take a look at 2 more. Hopefully, again, you're noticing this one. This one's going to be an OR because I have shading in an outwards direction, or outwards. So I know I'm going to have the word OR. An X for each of my inequalities, or whatever letter you choose to use. This one I'm shading towards the left, so I want to have the little end and my -1. And then for my other one, shading towards the right, thinking about greater, so x is greater than 2. Again, both of these are open inequalities because they have open circles on them, so we don't have to worry about the greater than piece. Unlike my last one here, this is an example of one where I have a closed circle, so one of my inequalities will need to have the equal to part on it. This example, notice that we're shading in between the two inequalities. So I want to make sure that my inequality has the x situated between two less than signs. My smaller number is -3, and that has an open circle, so I don't need the inequality sign. 3 is my biggest number. This has a closed circle, so that one needs the inequality sign. So the rest of the time then is yours to work on the compound inequalities worksheet. Most of them are going to be where you're solving and then graphing the compound inequalities. And then there's just a handful on the second page where you are writing the inequality that would match with the graph.